Welcome to Notes 8.4. Today we're going to talk about some more kinds of quadrilaterals. We're going to talk about ones that are all parallelograms, but they're special kinds of parallelograms. So let's do a bunch of definitions. All right, we are going to begin with the rhombus. The rhombus is a parallelogram that has 4 congruent sides. A rectangle is a parallelogram that has 4 right angles. And a square is a parallelogram with 4 congruent sides and 4 right angles, which means that all squares are both rectangles and rhombuses. So all of the properties that apply to parallelograms, both pairs of opposite sides parallel, both pairs of opposite sides congruent, one pair of opposite sides both parallel and congruent, opposite angles congruent, and diagonals bisect each other, those all apply to all of these. And then there are some special properties that just apply to each one of these. So let's continue on. All right, we need to indicate whether this statement is sometimes, always, or never true. And I think sometimes if you draw a quick Venn diagram, it maybe helps with these a little bit. So if we have this big box, we're going to call this our quad box. Okay, within that, there's a subset of quads, a fairly large subset that's known as, that should all be in the box. Sorry, I just can't draw today. So these are parallelograms. And then within my parallelograms, I've got a subset of those that have 4 right angles. So those would be called rectangles. And then I also have a subset that has 4 congruent sides, and those would be called rhombus. And then right here in the middle, the things that have both 4 right angles and 4 congruent sides, those are my squares. Okay, so let's kind of refer to this as we're doing these sometimes, always, never statements. All right, if a quadrilateral is a rectangle, then it is a parallelogram. Well, if it's a rectangle, it's in this red circle. If it's in this red circle, it's definitely in this purple circle, which means that it is always a parallelogram. All right, if a quadrilateral is a parallelogram, then it is a rhombus. So if it's a parallelogram, it falls within the purple. Rhombuses are in the purple, but there's also stuff outside rhombus that still falls under parallelograms. We're going to have to go with sometimes for this one. If a quadrilateral is a square, then it is a rhombus. Okay, so square right here, a square means that it has 4 right angles and 4 congruent sides, and anything with 4 congruent sides is always, I don't know where my eraser went, always a rhombus. If a quadrilateral is a rectangle, then it is a rhombus. Well, that's only true when it's a square, so that would have to be my sometimes. If a rhombus is a square, then it is a rectangle. Squares have 4 right angles, so squares are always rectangles. These can get a little bit tricky. You just have to figure out what works best for you, whether it's draw a Venn diagram or just keep reminding yourself of the properties. But we are going to do a bunch of either true, false, or sometimes, always, never. And you're going to need to have those properties understood completely in order to not get yourself spun around. All right, then we got some corollaries. They're sort of almost the definitions of these terms. So a quadrilateral is a rhombus if and only if it has, what makes a rhombus a rhombus? 4 congruent sides. Okay. A quadrilateral is a rectangle if and only if it has 4, well, what makes a rectangle a rectangle? 4 right angles. And a quadrilateral is a square if and only if it has 4 congruent sides and, oops, I guess I didn't need to write this 4 there, sorry, and 4 right angles. So a square is both a rhombus and a rectangle. So all squares are rectangles, all squares are rhombuses, but not all rhombuses are squares, and not all rectangles are squares. Just keep that in mind. All right, so we're talking rhombus here. We got rhombus RSTV, so let's draw a picture. RSTV, and then we're going to draw the thing that makes rhombus a rhombus, which is 4 congruent sides. So I'm going to show that all my sides are congruent. And angle S is congruent to angle B. Is that sometimes, always, maybe even never true? Well, in this case, that is always true. Right? These are opposite angles, and all rhombuses are parallelograms, which means that opposite angles are congruent. So in a parallelogram, if parallelogram, then both pairs, opposite angles, are congruent. All right, what about T and V? Are T and V going to be always or sometimes true? Well, in this case, it would be a sometimes, and that sometimes would be if it's a square. If it's a square, then not only are there 4 congruent sides, but there are 4 right angles, which would mean these 2 angles are congruent. Otherwise, they're just supplementary. All right, I am going to ask you to do this one in the notes check. Okay, tell me the best name for this quadrilateral. You're going to have a multiple choice from anywhere from parallelogram down to square. Right? And we want the most specific, and I need you to find me the remaining angles. Okay, here we have some more special properties that you are going to need to have solidly understood. In a rhombus, the diagonals are perpendicular. So a parallelogram is a rhombus if and only if its diagonals are perpendicular. So AC must be perpendicular to BD. And furthermore, a parallelogram is a rhombus if and only if each diagonal bisects the opposite angles. Okay, we know that the diagonals bisect each other because it's a parallelogram. But in a rhombus, they also bisect the opposite angles. All right, and that's a lot to write, so I'm not going to write that over here. And then we have one for rectangle. A parallelogram is a rectangle if and only if its diagonals are congruent. So in this case, AC would be congruent to BD. So not only in a rectangle do the diagonals bisect each other, but they are also congruent. So that's an important thing to remember about rectangles. All right, so here we have rectangle WXYZ, which means we got this going on, all right, because that's what makes a rectangle, 4 right angles. And they intersect at point O, and we are given that this angle right here is 56 degrees. That is enough information to find the measure of every other angle in this figure, believe it or not. And we're going to ask you to do that. All right, and here's the reason why. Well, these 2 angles are complementary. So if this angle is 56 degrees, then this angle must be 34 degrees. Okay, now I can find every other angle. They're all going to measure one of these 2 things, except for these 4 central angles here, and we'll talk about those in a second. Now, we know that the diagonals of a rectangle bisect each other, so that's true. And we know they're congruent, which means that this must be true also, which means I have 4 isosceles triangles going on here. So all my base angles are going to be congruent. So I've got 34, 34, 56, 56. And furthermore, I know that because it's a parallelogram, my opposite sides are parallel, which means my alternate interior angles are congruent. So if this is 34, this is 34, and then because this is an isosceles triangle, this is 34, or because these were complementary. Same thing here, we've got 56 and 56. Okay, so that tells me, first off, let me see, we need ZOY. Oh, haven't found ZOY yet. ZOY is this angle right here. Well, I know that all of the angles in a triangle sum up to 180, so I take 34 and 34 and I get 68. So 68 plus the measure of angle ZOY has to equal 180, which means what is the measure of angle ZOY? 112 degrees. And then XWO, we already found. That one is 34 degrees. That's going to be a little degree symbol. That's a terrible degree symbol. Oh, and that's a big eraser. Wow. 34 degrees. That was 112. All right, and then XO. Well, we know that WY is 33, which means that ZX is also 33 because my diagonals are congruent to each other, which means that O is half of that. So 33 over 2 works just fine. Or those of you who like decimals, I guess you can go ahead and do decimals if you can't handle fractions. All right, on to the fun stuff. So without using graph paper, classify the quadrilateral ABCD with vertices at the given coordinates. Okay, so all we know is that ABCD is a quad. That's it. We don't know what kind of quad. And then we're given some coordinates. Now, even though we're not allowed to use graph paper, I do like to draw a sketch of it to kind of see what I'm working with and help me sort out what properties I want to use. So A is at -3, 4, so we'll just draw A over here. B is at 0, 6, so it's to the right of it and above it, so we'll go with B here. C is a little bit to the right and a little bit below that. So there's C. And then D is a little bit to the left of B and below all of them. So there's D. All right, so it looks something like this. Not totally sure what that means, and I didn't draw it very accurately. But first, let's decide whether it's a parallelogram. Because if it's a parallelogram, then I need to go further. But if it's not a parallelogram, then I'm stuck at quad. So what are the ways we can prove a parallelogram? Well, I can prove opposite sides parallel. Or I can prove opposite sides congruent. Or I can prove one pair of sides parallel and congruent. Or I can prove that the diagonals bisect each other. And I think I'm going to go with that one, which means I need midpoints. So I need the midpoint of AC, and I need, I don't think I should write an M there. That looks like slope to me. Make capital M of AC and a capital M of BD. All right, so for AC, I add the x's, -3 plus 2, and divide by 2. I add the y's, 4 plus 3, and divide by 2. And that gets me -1/2 and +7/2. All right, when I do the same for BD, I get 0 minus 1 over 2 and 6 plus 1 over 2. So I, again, get -1/2 and 7/2. So if my diagonals bisect, which they do because they meet at the same midpoint, then I have a parallelogram. All right, so I at least know it's a parallelogram, but now I need to see if it gets any more specific than that. So I need to check and see if it is perhaps a rhombus. Well, if it's a rhombus, all 4 sides are congruent, so I can find the length of all 4 sides. That will give me that it's a rhombus. Or I know if it's a rhombus, then the diagonals are perpendicular. So I think that's an easier way to go. So let me see if the diagonals are perpendicular to each other. So in order to do that, I need to find the slopes of the diagonals. So now I'm going to find the slope of AC, which is change in y over change in x. So I'm going to take 3 minus 4 and 2 minus a minus 3. And I get -1 over, that becomes 5. All right, and then I'm going to find the slope of BD, and that would be 1 minus 6 over -1 minus 0, and that gets me -5 over -1, which is +5 over 1. So these two are perpendicular to each other. So diagonals, if diagonal is perpendicular, then rhombus. So the only other thing it could be that would be more specific is I need to check and see if it is a square. How would I do that? That is the question that I want you to answer in the notes check. Is it a square? If yes, how do you know? All right. I'm going to end part 1 of the notes here. Please continue on to part 2.